Hello, and welcome to 5-Minute Math. Today we are looking at the 6th grade concept of wholes, parts, and percents. This is Standard 6.5b in the great state of Texas, and we are using item number 26 of the 2024 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we've got a small little situation here. We got a park. 40% of the trees change color. There are 500 trees in the park. So how many trees in the park change color? So we need to find the number of trees that change park. Well, there are several ways that we could solve this problem. Let's look at several of them and see if one of my methods matched yours. All right, so I want to first draw a strip diagram. There are 500 trees in the park, so that's going to represent my total. Okay, I've got 500 trees. Now, normally we would have another number underneath that, right, for the part whole. In this case, we have a percent. And I know that 40% is a little bit less than half, so I'm just going to put it right around there. And I'm going to say 40%, right, change color in the fall. Now, I'm not asking for this other percent because that's easy. That's going to be 60%. That doesn't change fall. The question is, how many trees in the park change color? So that's this right here. So what I really need to know is what is 40% of 500? And if I can turn that into an actual number, then we're good. So let's look at the different methods that we could use to solve this problem. One method would be to set up a proportion. Okay, so we can take 40% and we can say, you know what, 40% is 40 over 100, right? That's what percent means. It means per 100 because you've got 100 cents in a dollar. Percent means out of 100. So 40 out of 100, okay? And then really what we could look at is we're trying to figure out, well, how much out of 500 would that be? So I'm going to set up a proportion here. Really, it's just two equivalent fractions. So if 40 out of 100 changed colors, 40%, how much would that be out of 500? And you see, right, what I'm looking for is I'm looking at relationships. I'm thinking, how do I change my denominator from 100 to 500? Well, I can multiply by some type of equivalent fraction. 100 times what gets me 500? Well, that's 5. So if I want to make an equivalent fraction to complete my proportion here, I need to multiply by the same numerator and denominator because 5/5 is the same as 1 whole, which means I'm not changing it, I'm just making it look different. So what is going to be my 5 times 40? That's 200. So that looks like that could be an answer there, 200. 200 out of 500 is the same as 40 out of 100. They're equivalent fractions. What's another way that we can solve this? Well, what we can do is when we think of 40% of 500, we can think this means that's a multiplicative relationship. So I want to do 40% times 500, but I'm going to change my 40%. I'm going to change that into a decimal. So I'm going to move the decimal over twice, or think 40 100ths, right, will reduce to 4/10. So really this is 0.4. 40% is 0.4 or 0.40. I want to multiply that by 500. And look what I get here. Right, it just means 0, 0, 20, just a whole bunch of zeros. So it looks like 2,000, but remember, you've got one digit behind the decimal here. So I need one digit behind the decimal here. And look, I end up with that same answer, that 200, right? And if we wanted to, we could just verify that the other half makes sense, right? The 60%. So this is the 60% that doesn't change. So we could do 500 times that 60% that doesn't change, and you're going to get that 30, which is going to end up being 300 once you put the decimal in there. And that makes sense, right? If 40% does change, that's going to be my 200. This is going to be my 300 that doesn't change. And those two together do add up to that 500, which we were looking for. So my answer is B.